We're going to work on problems for week 3. So, what do we have? Question number 1. Y varies directly as x and inversely as the square of z. Okay? Y varies directly as k, directly as x, right? Yes. Directly as x. How we show that varies directly as x? We use coefficient of proportionality. Okay, and inversely as a z squared. If it would say in that directly as x, we would have y is equal kx. It would say only inversely to z squared, we would write down y is equal k by z squared. Okay, but it's varies directly as x and inversely at z squared. Okay, let's write down now the data so we can solve it. What do we have? Our y is 39, okay, x is 27, and z is 3. We need to find y when x is 50 and z is 5. How are we gonna solve? All right, let's write down. So we need to find y. We have x is equal 50, z is equal 5. Okay, so well, let's plug. K times x is 50 and divided by z, which is 5. So we can find this y because we don't know k. How we can find out k? K we can find out from information we had that y is equal 39 when x is equal 27 and z is equal 3. Let's write down 39 is equal k times 27 and divided by, oops, 5 squared here, I'm sorry. Okay. And z squared is 3 squared. So from here I can find k. From this one I cannot find k because I have two variables. Here I have only one unknown, right? Therefore, I'm going to find from here k. So we get 39 is equal 27k divided by 9. Well, I'm bringing to common denominator if I take this equation 9. Actually, okay, it's 27 and 9, we can go easier way. It's going to be 3, 1 and 3. So we get k 39 is equal 3k, right? And to find k, I need to divide by coefficient of k, dividing by 3, dividing by 3. This is gone. And this is also 1 and 13. So k is equal 13. Okay, now I can plug k is equal 13. And let's solve this one now. Y is equal 13 times 50 divided by 25, right? 5 squared is 25, so I can, the 50 divided by 25, it's going to be 2. And 13 times 2, it's going to be 26. So my answer is going to be 26. Let's type it in and check. Bingo. Moving to next question. Okay. What is our next question? All right. So y varies jointly as x and z. Okay. Y is equal 84. And when x is equal 7 and z is equal 2. Find y when x is equal 5 and z is equal 6. So what formula it's going to be? y varies jointly as x and z. That means it's both ways, it's gonna vary, both variables is gonna vary as a directly proportional, which we're gonna write down, this number 2. Y is equal k x z. Okay? All right. So we need to find y. Y is equal question mark when x is equal 5 and z is equal 6. But what we are given here, we are given that y is equal 84 when x is equal 7 and z is equal 2. I will write down this way so you would know which set of given data belongs to which y. All right, so again from here, y is equal kxz. We have y, we have x, we have z, so we can find k, right? K from here, it's going to be equal, let me see, if we treat it as a equation, so k and z, it's going to be coefficient for k. So I'm going to get rid of it, do opposite operation to multiplication, which is division, because I need to get only k, therefore I need to get rid of x and z. To get rid of x and z, I have to do opposite operation. This way it will cancel each other, right? And the same operation we do to other side of equation. So whatever change we do to one side of equation, we have to do to the other side of equation. And from here, y over xz is equal k. All right, let's plug in. Y is 84, x is 7, z is 2. That's equal k. So 84 and 7, I believe 14, 28, no, 98 it makes, okay. Yeah, I'm wrong. All right, by 7, let me see, 84 by 7, it's going to be, wait a minute, did I multiply it wrong? 84 divided by 7 is 7, 14 by 7, 12. Yeah, well, previously I multiplied wrong. Let me multiply one more time. 14, 7, 8. Well, I don't know what I did wrong, but it was wrong. So this is going to be 12. This is going to be 1. And now I am going to 12 and 2. Divide by 2 is 6, right? This is 1, this is 6. And we are getting k is equal 6. Back to our problem and plugging k as a 6. We found k is equal 6 from here. Y is equal 6 times 5 times z, right? Because we have k, x, z. And what do we get? 6 times 6, 36. 36 times 5, 30. 15 and 380. Okay, let's go back. Punching 180. Nice work. Question number 3. Write an equation that expresses the relationship. Solve for the equation for h. So f varies jointly as h and z. Okay. Question number 3. F varies jointly. This is our the coefficient of proportionality, or otherwise I call it constant, as varies as what letter? H and Z. Okay. H and Z. So we need to find, we need to plug this formula first. K, H, and Z. Nice work. Now we need to find H from here. To find H, I'm going to rewrite this way, K, Z, and H. So if this H is my X unknown, I need to find out, then I have to divide by K and Z, right? Because K and Z is going to be my coefficient of H. And the same thing, same operation I have to do to the other side of equation, K and Z, right? Okay, So K and Z here is gone, and we get H is equal F over K and Z. Okay. Uppercase F over K and uppercase Z constant. Okay, moving to question number 4. Let me see what we have here. Okay, give me 1 second. I wanna check here something. Yeah. So what do we have? Write an equation that expresses the relationship. Okay, similar question. Solve the equation for G. So Q varies jointly as G and square of C. Okay? Q is varies jointly as C and Q squared as G and square of C. Okay. As C, it's a Q and square of C. K, J, G, and C squared. Okay, let's write down. Jointly as G, so coefficient K, and then G and C squared. Bingo. And from here, G is going to be equal, look here, if G is my X, then K and C squared is going to be my coefficient, right? I have to divide by coefficient. And the same operation I have to do to the left side. So Q also divide by K and C squared. Let's do it. Q divided by K and C squared, right? Fantastic. Question number 5. BMI takes both weight and height into account when assessing whether an individual is underweight or overweight. BMI varies directly as one's weight. Okay, taking a note directly, which is going to be BMI equal, I will write down in the notes, as number 5. BMI varies directly as weight, okay. And inversely as a square of one's height in inches. All right, square of height in inches. All right, we have it. So in adults, normal values for BMI are between 20-25. 20-25 BMI is a normal, inclusive. Values below 20 indicate underweight, and values above overweight. A person who weighs 180 pounds, okay, let me write down, weight 180 and 5 feet. Okay, so BMI, weight 180 and height is 5 feet, which is going to be 60 inches, right? 5 times 12. Okay. Or 60 inches, okay. Tall has a BMI of 35.15. Okay, writing down. 35.15. Okay. Next, use the 4-step procedure for solving variation to determine what the BMI is to the nearest tenth. For 100, let me write down first so I won't go forth and back again. for 175-pound person who is 6 feet and 1 inch. Okay, is the person underweight, overweight, and or normal? All right, let's get to work. So we need to find BMI question mark for weight is 175. Yes, was it 175? Yes, 175 pound, and height is 6 feet, 6 feet and 1 inch. So 6 feet is gonna be times 12, 12, 6, 72 feet, and 1 inch is gonna be 73 inches, right? Okay, converted 6 feet to inches and 1 inch, 6 feet and 1 inch. Okay, so we have the formula. BMI is equal K times W divided by H squared. Okay, so what do we have? We have our W, we have H, right? We need to find K. That's what we need to know. And this K we're going to find out from this BMI, where we have BMI is equal 35.15 and it's equal, so K times weight is 180 and H squared, it's going to be 60 inches squared, which I'll put 60 times 60. Yes? So 180 and 60, this is 1, this is 3, correct? And then 60 and 3, it's going to be 20. This is 1, this is 20. And we are getting K over 20 is equal 35.15. I rewrote K over 20, moved to the left side, so we just have it. So we need to find K. To find K, we need to get rid of 20 because we divide by 20. We have to do opposite operation, which is multiply. And since we multiply on one side, we multiply to the other side. This is gone. And K is equal 3515 times 20. Okay, 3515 times 20. This is 2 times 5 is 10, 1 in mind, 2 and 1 is 3. 2 times 5 is 10, 1 in mind, 2 times 3 is 6, and 1, 7. 7,030, and this 0 adding here. Okay, we have two decimal notations, right? So decimal here, 1 and 2, 703. All right, our K is 703. We got K. Let's go back and plug to our BMI that we need. Find out our BMI. So BMI is equal 703 times W is 175 and H is 73 times 73. Interesting. Let me see if 175 I can divide by 73. No, it's not. And 703, let me see if I can divide by 73, see if I can simplify as much as I can. No, it's not. Okay, then we have no choice. We have to go through big numbers. Yes, so first we are going to do multiply 703 times 175. Okay, we get 123,025 and 73 squared, 73 times 73, I'm getting 5,329. Okay, let's divide 123,025 divide by 5,329. And we are getting 23, because it's asking for rounding till first decimal, so 23,085. I'm going to get 3.085. It's going to be approximately 23 and 1. All right, let's write down 23.1. Fantastic. Okay. And what do we have? 23.5. It's a normal weight, right? Between 20 and 25. Moving to next question. Okay, approximate the number using calculator. So all we have to do, we have to take calculator. Let me see. I need to take my scientific calculator. Okay. So what do we have? 3 to power 2.8. So I'm choosing, I have iPhone, so I'm punching 3 and then clicking X to power Y button and 2.8. And I'm getting, we need to put 3 decimal notation, which is going to be, I'm getting 21.3.674. Excellent. So first I typed 3 and then I click on X to power Y button and then to power 2.8. Now every the calculator working different way. I used iPhone, so whoever has iPhone can follow me. Next, e to power 1.2. Where is my e? Every phone that has letter e, because e is known as a growth constant, the constant 2.71, 2 and whole 9 yard decimal. So I have e in my scientific calculator. So I'm going to punch e and then X to power Y, and my power is 1.2, and I'm getting 3.320. Why I add 0? Because it's asking for 3 decimals and I don't have rounding to anything higher. All right, fantastic, very good. Next question. So next, fill in the blank so that the resulting statement is true. Okay, we are moving to logarithm. Logarithm is opposite to exponent. Not the opposite, but another way, because opposite will be square root. Another, not square root, radical rather saying. So logarithm is another way of writing down exponents. So let me explain you what we are doing here. This is question number 8. So if I have 3 to power 2 is equal 9, to write down in the form of logarithm, I'm going to write down logarithm 9 to power, by base 3, because this is our base, what we call, is equal to. Which means when I'm reading this logarithm, I'm reading following way. Base taking to power 2 I'm getting 9. Let me write down base, taking to power 2, I'm getting 9. Let me take another one. 3 to power, okay, enough 3. Let me take something else. Let me see, 2 to power 4. 2 to power 4 is 16. If I want to write down in the format of logarithm, I'm writing down logarithm of 16 by base 2 is equal 4. And I'm reading, if I want to write backwards, so base 2 raised to power 4, I'm getting 16, right? 2 to power 4, getting 16. Now, what if I have, let's say, logarithm 3 by base 3? How much it's gonna be? This is question mark, so 3 I have to raise to what power to get same 3? Power 1, right? Okay, so here we have b and b. That means I have to raise to power 1 to get itself, correct? Well done. Bingo. What is next? We have 3 is equal logarithm 8 by base 2. So we need to rewrite. Let me write down here. Logarithm 2, logarithm 8 by base 2 is equal 3. So if I want to write down as in the form of exponent, I'm going to take 2 to power 3 is equal 8, right? And that's what I'm going to put it here. 2 to power 3 coming down here equal, one more time, 2 to power 3, okay, equal 8. Nice work. Next one, 5 to power 3. We're going to write down opposite direction now, right? So 5 to power 3 equal 125. So since already we practiced, I'm going to write down straight. It's going to be log. Oh, this is I. Where is my L here? Oh. log log 125 by base. Let me see if I can find base more, clicking more. Let me see if I can find logarithm. Oh, here it is. I need to clean this. Okay, let's go back. I'm going to clean this. How I'm going to clean? I have no idea. Okay, well, clear all. Okay, good. We cleared all. So writing over again. I really don't know how to. Okay, finally, thank God. All right, so I'm typing here logarithm log. Okay, here is this index by base. What is going to be my base? It's going to be 5, right? Because in exponents, 5 is our base, 5. And then here it's going to be 125. and all this is gonna be equal exponent free. Finally we made it. Bingo. Let me go to here and explain. So 5 to power 3 equal, is that what it was? 5 to power 325, yeah. Okay, 125. So we are writing down logarithm this 125. This is our base, come here, and here is 3. So we are getting 5 to power 3 equal 125. Okay? All right, next question. Question number 11. So square root of 25 is equal 5. What do we need to do? Write down in the form of logarithm. Let's do it. No. Square root of 25 is equal 5. Okay, 25, square root of 25, I can write down 25 to power 1/2 because 25 has degree 1 here, and square root, that's by default meaning 2. Here it is. Let me write down again. 25, it has degree 1, and this square root is usually, when we don't put any degree, that means it's 2. And that is equal 25 to power, this 1 comes to numerator, 2 comes to denominator. 25 to power 1/2 equal 5. So which means logarithm 5 by base 25. Every time when you see base is greater than result, then definitely you can you will know, and you can be sure that exponent is going to be fractional. Okay, because to get from bigger number small, you have to raise to fractional exponent, correct? Okay, let's write down now. Again, logarithm, we said 5. No, logarithm 25. And here is 5 is equal 1/2. Well done. Okay. Next. What is this one? Find the exact value. Okay. How are we going to work with this one? So, logarithm 144 by base 12. What does that mean? That means we need to raise 12 by what power to get 144? Well, I know that for a long while that 12 squared is equal 144. So which means it's going to be 2, right? Okay, let's write down.